Hello, everybody. Um, my name is Anton Kranga, and I am a full-stack developer and with some experience of doing Java development. I primarily do Java development, and last 5 to 6 years, I completely dedicated to the cloud domain, and I also doing a lot of DevOps evangelism in my company Accenture. And today I will speak about something that we do in our project, which is Accenture Cloud Platform, and something which I believe is quite interesting. And yeah, let's start. So today we will speak about data architecture, and because I'm doing a lot of cloud computing, so we basically will try to narrow it to the cloud computing area. So let's start with the motivation. So basically, whenever we need to create big data or complex data project, we really need to think about how do we plan our architecture, how do we plan our data, and so on. And specifically, if you want to put word big data or Hadoop in your stack, then you need to think really twice. So today, basically, when we speak about big data, then we typically speak about data streaming. So what does it mean, the data streaming? That means that we have continuously some data appearing from some, let's say, data source that can be any wearable device like my one. It can be your smartphone. This can be even server if you do monitoring tasks. And then you need to constantly consume this data and store it for further processing. Well, not really, because primarily what our users expect that as soon as you were able to get the data, then the users believe that it will appear in the report immediately or almost immediately, which not always true when we deal with big data analytics, because traditionally big data analytics relies on the heavyweight batch processes that runs for a long period of time. Second challenge that we have, and this is specifically to the streams, it's we need to be fault tolerant, because if something goes wrong, then we need to be able to recover, because we have some other, like, more, I would say, system administrator concerns like scalability, we need to address this as well. So especially if we scale out, there is not problem. We add more computer power to do our stream processing, but when we scale down, we do not need to lose our data. So this is something that appeared relatively recently that we call Lambda Architecture. So basically, this is an alternative to the traditional batch processes, which is typically operates like in a standard, like ETL style, where we're taking the data extraction, we're transferring it to somewhere, probably to HDFS or from HDFS, and then we load the data. Right? From here, what we do, we basically, once we got the new data arrived, then we split it. And part of the data we store in the traditional MapReduce heavyweight process, and this will be our master data. But but at the same time, we in parallel we process it with the data streaming algorithms, and we basically why do we need it? Because we want to this data to appear at the same time on the user's view. So, but here is a challenge, right? Because something that we call speed layer, which is really oriented on the message processing as soon as data arrive, it has a big throughput, but it does not work with a big volume of data. It can produce some errors, some calculation errors. Then this is why we need this heavyweight batch process that works slowly, computes slowly, but without errors. So basically what is happening, we catch all streaming data on our speed layer, and then we correct if there is any mistake in the speed layer, we correct it with the data that was calculated by our heavyweight batch process, and then we continue again, right? It is this process, and then when we have done this, we can prepare the serving layer, which will be really how do we want to display the data, how do we want to show it, or how do we want to store it. This is something that's already prepared for user consumption. So then there is a question. If you remember, I promised you that we will do closer to the cloud. And first question, why should we go to the cloud, right? And especially to be something that we call cloud native. That means that we want to utilize as much as possible native components of our cloud provider, which in today's case will be an Amazon, and most probably that will be the only your cloud provider. So everybody who is not keen into the cloud, they say that we have the cloud provider lock-in. And by implementing native service, this is exactly what we want to do, right? And I totally agree. This is exactly what we want to do. I want to lock, by implementing a cloud native solution, I want to lock myself into the cloud and then accept all, I would say, possible architectural risks that can appear with that one, especially if somebody will want to acquire my cloud provider. And well, in my case, it's Amazon. So it will be very hard to acquire the Amazon. But at the same time, when I accept all this risk, I want to get something in return. First of all, what I'm looking for, it's something that I would say I don't want to do yak shaving, which is something like when I want to write, as a developer, I want to write some code. I want to develop my application, but instead of doing that, I will start with something that I need to provision some environments, I need to open some ports, I need to do something else, I need to add extra memory, I need to do many things, like I need to format my HDFS partition and so on, right? And instead of writing code, I do everything else possible. So this is what we call yak shaving. So what I want from the cloud, when I go to the cloud native, I want to start very fast. And I expect very high integration with multiple services of my cloud provider. So I would, ideally, I would be able to start write the code in a few minutes or few hours after I got into my cloud. Second thing, I want to rely on the managed services. If you ever worked as the operations engineer or like system administrator, you know that database maintenance is hard. It's even more hard if you do big data infrastructure maintenance, right? It's not very trivial task. From that perspective, as developer, I don't want to mess with all things because this will be my yak shaving. I want to start to use, and I want to rely on something that is actually working, right? And from that perspective, instead of instantiating all these services by myself, I want to rely that it will work. And in case of Amazon, all services are actually where they promise it will work, it actually works, right? And it is really production ready and battle hardened. Then, because I go to the cloud, I should be able to automate all this stuff. I should be able to write my chef cookbook, Ansible playbook, or whatever automation I can imagine. I should be able to script into it. The Amazon has the nice concept that says that everything should be an API. When everything is an API, then we are able to automate it. It's one thing. Second thing, if you want to do on-prem provisioning of the same services, if you have tried to write your, I don't know, like Hadoop definition for Puppet or Chef, and you will understand me. This is not very likely process, and actually you can spend several weeks of writing automation. So, but my primary driver is actually the costs. When I closely integrate into the cloud provider, I should be able to write code that will run more efficiently and will be executed more efficiently with my cloud provider. What does it mean? That means that I can have a lot of cost savings. And last but not least, I should be able to integrate my solution with other services, right? Because in my case, the data provision architecture will not be just my alien service. It will be one of dozens of different services. And when I need it to be integrated with everything else, it should be done smoothly on the infrastructure level and on the API level. So one thing that I really like about Amazon, because when we do the Lambda architecture on Amazon, we basically simplify many things. In ideal world, our most simplistic blueprint for our Lambda architecture will look like this. So we all start with something that we call message, our new data provider, right? This is something that receives the message and receives the new data and then transforms it into the messaging system that Amazon Kinesis, in our case, can understand. I will speak about Kinesis in a little bit while, but Kinesis is a managed service for Amazon that is able to run, consume the streams, data streams, and in a very, very, very nice way. And it's actually, fault tolerant and cost effective at the same time. Then, when the data is consumed by Amazon Kinesis, it will be transferred to my Elastic MapReduce cluster, which will do my basically Hadoop or Spark or any other job. And at the same time, for longer processing, it will append to the long-term file system, which is based on my Amazon S3 storage, which is kind of slow. Yes, it's a little bit slower, but at the same time, it is highly available and elastic, right? That means that it's hard to imagine that I will run out of my disk space when I use Amazon S3 service. And then basically, in this case, Elastic MapReduce cluster will serve two roles. From one perspective, it will consume the streaming data that Kinesis API is sending, and at the same time, it will schedule the heavyweight MapReduce job that will go and read the data chunks which are stored in my S3 storage and transform it by itself. So let's speak about what are the services we can get from from Amazon Web Services, and let's speak about all of them in a little bit more details. First of all, let's start with the Kinesis. And Kinesis is something that is done in the way like it's I wouldn't say this is like a message queue, but it is actually a data streaming processing engine. So it works by the following. So it connects to the event producer that can be a virtual machine or any server that can send the messages to the Kinesis, or it can be Amazon Lambda service, and we will speak about Amazon Lambda in a while. At the same time, when it gets the message, this data will be replicated across 3 availability zones in the same region. That means that we should not be able to lose the data, right? And at the same time, once it is replicated across 3 availability zones, it is stored in the temporary storage, which is available for 24 hours. Once the data appeared, it will be stored inside of the Kinesis storage and available for you for collection for 24 hours. Right? This should be typically enough to process all your data with any sort of algorithm. Right? Then, basically, it will be this data will be available in the collection of data. Let's say like that, in the collection of records, and we can take the whole chunk by our consumer that can be Amazon virtual machine, which is EC2. It can be just storage, or this can be Lambda, or a few other services. So basically, there are a number of ways how we can later how we can consume and persist our data that we received from the Kinesis. So when I write my code, I basically what I need to do, I need to have to download my Kinesis client library. This is some kind of pseudocode that I wrote in Java, but just because I love this language, and I presume that majority of the audience kind of familiar with this language. Right. So basically, what I'm doing here, I'm saying that I will initiate a put request, and then I will store my data. I will store my data in the message, and then I will send it. Right. Then I will be charged by Amazon per each put request that I make. Right. So the right strategy actually to do it is actually to not to send the data as soon as it is arrived, but temporarily store it in the file. Then you can take one file, and if it is up to 2 megabytes, then you can send it as the one chunk. So once it was sent, then on the consumer side, on the right side, what I need to do, I need to get into my I need to request for my Kinesis. I need to find. I need just to find which one Kinesis stream I'm looking for. Then, what I say, I want to read my data with the option that is called by default trim region. This option is actually to start read from the oldest data that has not been read, and which is not 24 hours, old. Right. So basically, I will start to read my old data which was not processed. At the same time, I can also specify that I want to read the data in specific order by specifying that I want to read it in this sequence order manner. This is how we can maintain that the data which is streamed in the Kinesis which is streamed in the Kinesis in the parallel manner will arrive to you in the right order. Right. And then basically by iterating, when I read all my chunks, what I do, I'm just iterating through the old records, and then I processing it in the way I need it. Right. So just if to summarize what our Kinesis streams actually what's about, they really enables us to do the data streaming API, and typically when we need it for real-time or near-time analytics, log file processing, or reporting, and so on. As I mentioned previously, this data is durable. It is stored across 3 different availability zones in the same region. The costing model is quite interesting here. So basically what we charge it for, so one thing that when we stream the data, the Amazon Kinesis will produce something that we call shard. Amazon will calculate how many shards you need, but basically it uses the following algorithm. It will try to do the following. So one shard is able to read 5 transactions per second and maximum throughput 2 megabytes. And then one shard should be able to write 1 megabyte, and at the same time it should be able to do 100 write transactions. Right? And if you exceed this amount, you will get 2 shards. But virtually speaking, you will be charged for 1 shard approximately to $12.50 per month. This is 1 shard with the assumption that we every second read 1 megabyte of data. Read and write, yes. So then, if you are not able to process the data within 24 hours, you can request Amazon to store it up to 7 days, but that will produce more. But honestly speaking, I think 24 hours for me, it's hard to imagine the use case when you need to store it when 24 hours is just not enough to produce to consume all the data. But yes, it's possible to ask Amazon to extend that one. So when it's not good, Kinesis, when you do when you deal with small streams, right? If the stream is so small that you just you barely consume less than 200 kilobytes, then it's not advisable to use this, to use streams, because there are other more effective methods how to deal with this, and at the same time. And at the same time, just the overhead will be too big on your application and on your cloud account. So, and then, of course, if you need more than 24 hours to store the data in this temporary storage, that's probably you need to think twice. Do you need Kinesis at all, right? Because you probably something do really wrong. So the next service, which is, by the way, my favorite, called AWS Lambda. Please do not confuse it with the Lambda Architecture. This is completely different stuff. Lambda, this is a special service that kind of enables you to write piece of code in what we call like serverless state. That means that you write the code, you transform it into some sort of I would say so you basically you write the code, you put it in the zip file and upload to the Amazon, and you declare that this will be my Lambda function. This code has a few constraints. It must be stateless. So you basically will not have the place where you need to store the data, any data, right? And then this code must be written with the assumption that it will be executed asynchronously by the Amazon and scale it if it's needed by Amazon. But you will be charged per one execution. But the execution cost is very, very cheap. So it is approximately, well, I will, in the next slide there will be some numbers, but it's the execution is very cheap. So basically, the Lambda, to me, this is very nice alternative to the hosting the full-blown services instead of you just rely on its execution. Right. So yeah, the cost model. So basically, you are charged per gigabytes per second. With the smallest amount, so gigabytes per second, that means that how much input-output operations you do, and per every second. And the minimum step is actually 100 milliseconds. But at the same time, you will see that the charge is 20 cents per 1 billion requests, with the assumption that each request has been executed as 100 milliseconds, which is quite cheap, right? We have very great appetite in our product that we're building for Amazon Lambda, because we believe that moving our costs, our processing power outside of servers into the Lambda, we will get up to 10 times savings from these services. So, but there are a few things that we need to remember. First of all, Lambda has a timeout which is 5 minutes. So basically, your execution of your code cannot exceed 5 minutes. And this is something that you cannot change, even by begging Amazon to do it. So second thing, which is quite funny, we really need to think how to write code without relying on persistence. Right? We getting some information from in the format of messages. We're applying some function to it, and then we return another message, and that's it. And you need really to design your application around of such kind of communication. There is a way how you can store your, you can host your website with all your operations and so on without any server in the classical meaning of Amazon, right? But and it will work. The only thing that if your data is highly volatile, it changes a lot, then it will not worth it. And last but not least, there is a competitor which was released a few weeks ago. This is extremely small virtual machine called Nano, and it is quite cheap. It's extremely cheap. So whenever you do Lambda, you need to think how much it will cost. And for many operations, you might want to go back to the traditional nano VM powered operations just because you have lesser restrictions, and it might be cheaper. So in practice, this is how Lambda looks like. So we have the message event sources for Lambda, and this can be either our Kinesis, this can be storage, So Lambda can be triggered by the moment when somebody writes to our storage. Right? You can trigger Lambda by notification service, which is SNS, or you even can run Lambda as in some kind of periodical manner, as the alternative as you would do the cron jobs. Traditionally in Amazon, we had to create a new servers just to be able to trigger events at 5 o'clock every Thursday, right? With this kind of approach, you don't need it. You just need to say Lambda, do it, and then that's it. Then you pack your application to the zip file that can be Java 8, Python, or Node.js, and other runtimes are coming, and then you will produce. You do your operations, and then you will export it within to the consumer. That can be quite a similar service. Next service that's called EMR, which means Elastic Map Reduce. So this is something that is really full-blown Hadoop cluster. This Hadoop cluster can be powered with, with majority of the big data products, including Spark, Hive, Pig, or and so on. Right? So this is something that Amazon runs as the managed service. So yes, it is baked by real VM, but this VM is managed by Amazon. This is controlled by Amazon and installed and provision it by Amazon. So it is pre-configured and it works. At the same time, it gives you back the full. It gives you back the full reporting on what's happening inside of the Hadoop cluster, and even more, you can scale it when you need it. Right? The only problem that I was able to find with this, it consumes very large and expensive servers. Right, so basically, whenever you want to add EMR into your architecture stack, then you will get much more bigger bill in your Amazon account. But at the same time, it's still I find it will be better than you would provision the same configuration by yourself. So the cost model, so basically it charges you per the size. So Amazon does not charge you at all. It gives the service for free, but at the same time, because you buy a virtual server from them, they will charge you depends on what you actually purchase, right? And it depends on the size and number of RAM, core, and so on in the server. At the same time, if you want to persist, and probably you will want to persist the data in external storage, you can be charged with additional cost. So for example, if you consume the S3, which is highly available storage from Amazon, you will be charged per, few cents per gigabyte. So, but at the same time, when you want to scale your cluster, it will scale. If you want to downscale, it will downscale. The only thing that when you want to downscale, you need to externalize your storage to somewhere else, like S3. So when you shouldn't use this data, basically, primarily when you do not really need Hadoop. When you do not need processing of heavyweight map reduce jobs, then basically just don't do it. Don't use it. Traditional problem of all NoSQL databases, it is ACID, which is atomicity, consistency, isolation, durability. So you might have some issues there, right? And actually, I would say MapReduce just in general have a very strong competitors because if you do not need, I don't know, if you deal with the data with less than 100 gigabytes daily, right? You might just survive with the database, right? And from that perspective, there is quite tough competition from the managed relational database as a service from Amazon, which is DynamoDB for NoSQL database, or AuroraDB, which is highly scalable MySQL engine, right? Very fast. So then what we also have the S3 storage. Well, this is very simple. Just think about it like a very big hard drive that never ends and the data never lost. But you will be charged per each gigabyte of this data. But however, the pricing is quite attractive. So this is one of the few services where Amazon is covered by a service layer agreement, and it actually gives you a possibility. Well, it actually promises that the data that you store there will be there. However, what we see, there are several liability criteria for the data, and actually standard storage with the implement redundancy, reduced redundancy, and Glacier storage, which is typically used where you need actually to archive the data because it does not guarantee that you can read it. It will store it, but you are able to read only some portion of the data, which is okay for backups, and especially if you compare the price per gigabyte, is just amazing. But the limitation that you are able to read something about 5% of the data that you stored. So when you do not need S3, basically when you have performance issues, because S3 by default implements the redundancy on the backup side, you will be it is not as fast. You barely will want to mount your database data into S3 because it will be extremely slow. So, but at the same time, for a majority of big data jobs, it's okay. Right. So Redshift, this is I would say fully managed by Amazon data warehouse, which is primarily targeted for traditional ETL processes, which is like OLAP analytics and so on. What is interesting, it scales in all directions. At the same time, the cost model is quite good, and yeah. So and at the same time, a few limitations like because this is data warehouse, you typically store it for you need it for your statistical data, right? But you do not put your blob storage there, and it will be extremely slow and inefficient, and at the same time do not store some unstructured data. This is not Hadoop. This is a data warehouse. And at the same time, because it has some, I would say, parallel, it processes the data in a very parallel way. Basically, when you store the data, it will not be immediately available for reading. Right, so for OLTP, something like we typically have in e-commerce applications, just with typically our websites, this is not good database, and this is again, this is if you need OLTP, then you probably will go with the relational database storage. Yeah. So taking into account all this stuff, what we typically can have is can be look like this. So we have a producer, which is Kinesis, which can be a server with a Kinesis client inside, or it can be Amazon Lambda. So then when it streams the data that it was able to read from somewhere else, and then Kinesis computes how many shards you need. When you write your application, you typically do not really have a control about how many shards you need. You just you have an assumption that you will always iterate through the shards for the latest data. But at the same time, this will give Kinesis possibility to transfer a huge amount of data every second. Then you write it. Then you write it for a batch process. You write it immediately to the S3, and then with the speed layer you can produce it. For some temporary aggregation. You can use Elastic MapReduce service for that, or in this case you can even use the Kinesis consumer that can just take the data, apply some simple calculation, just store it for the user. It will be corrected later in such kind of manner. We have a special Lambda function that is triggered every hour. And what it does is actually starts the MapReduce batch process that is happened here. It takes the data that was written in the S3 during the last hour, and then it creates does its job. The only thing that we need to worry about, this process needs to be finished within 1 hour. Right, and then when we and then basically and then when it's during this hour, the new data will be calculated by our speed layer, and then after 1 hour it will take the snapshot from the batch layer, and it will start to calculate it again based on the messages. Right. And at the end we store our data in the database and prepare for some representation area. What we also can do, we can implement some web UI, which can be our JavaScript application or whatever application, and this even can be Amazon Lambda to provide a nice API to the user. So what we have learned by working with all this stuff in our project, and actually we use it to be able to monitor and control over hundreds of thousands of servers every minute, and few things to mention. So it is better than a traditional MapReduce process or big data, but it's far not simple. It's far not trivial and requires a quite deep architecture design, and in this case it gives a lot of responsibility to the cloud provider. At the same time, we do not have really strict performance requirements that means that we are okay if the data that we just consume it will be available within I don't know, like a couple of minutes, and not just within a couple of milliseconds. Right? We really targeting not to the real time analytics. We're counting into the near real-time analytic, which is typically fine for our clients. We've got a problem with the automation, and specifically with the Elastic MapReduce. There are many things which are not yet fully covered by API on the Amazon side. So basically, there might be some challenges to write a fully blown automation script around that, so you would enjoy agility that typically DevOps processes gives to you. So that's about it, what I wanted you to share. I would happy to answer to any questions. All right. All right. Thank you very much. And yeah, well, I hope it wasn't so boring. And I know this is one of the latest talks for today. Okay.